Hello, Principles of Engineering. In this video today we're going to talk about inclined planes. Now we've talked about other simple machines and we've gotten far enough into it that I went ahead and I've written up the three different equations that we use. So we have ideal mechanical advantage, we have actual mechanical advantage, and we have efficiency. Okay, so we're going to actually work with these today. Let's see, we're going to use purple. And this time in an inclined plane, basically, if you remember back from when I talked about simple machines in the first place, we actually talked about lifting a weight and going straight up and setting on this ledge. And what we could do is trade distance for effort. So if we increase the distance, we can decrease the amount of effort that we have to put in to move this force. So by putting out a ramp, instead of moving it 0 feet this way, I've actually ended up moving it a whole lot longer. So the length of this ramp is the distance of the effort. So we're still going the same height, but we've increased our distance significantly. So by increasing the distance, we're going to end up lowering the amount of effort that we need. Okay, so let's take a look at this inclined plane. We're going to find the ideal mechanical advantage first. So if you remember, the ideal mechanical advantage is going to be the distance of our effort and the distance of our resistance. So let's fill in some of this information first. First of all, we have a 50 pound resistance here. Okay, we have a 4 foot height of what this thing is traveling. It's going up 4 feet. Now the distance here that the 50 pounds is being pushed, the resistance is being pushed, is actually 15 feet. Okay, so it's 15 feet there to there. Now this 50 pounds, this is going to be our resistance, and our effort is what's going to be being pushed in, and that's what we're going to try to find out here in a minute, is how much effort do we need to push in on this 50 pounds to get it to travel up this ramp. Okay, so let's take a look at what we know here. We know that the distance traveled, if we look at IMA, so let's change it to purple. So if we look at the IMA, we have the distance of the effort over the distance of the resistance. Okay, now the resistance is how far has it traveled, and we're looking at that. This is going to be H. So the distance that the resistance travels is a vertical distance. So vertical distance, or H. Okay, the distance that the effort travels is the length of this guy. So this is going to be L. So that's the length of ramp, or L. I'll put a line right there. Okay, so make sure that you have these correct, because those are the numbers you're going to use. So the distance of my effort, which is L, we end up with 15 feet over the distance of my resistance. The resistance traveled 4 feet high, so over 4 feet. Okay, and we end up with 3.75. Okay, so 3.75 is what our IMA, ideal mechanical advantage, is. Alright, so that's 1. In order to find AMA, or actual mechanical advantage, we're going to look up here again, and the actual mechanical advantage is the force of the resistance divided by the force of the effort. Okay, so if I change this up a little bit, and now I'm applying 20 pounds, so we've put this on a ramp, put a scale on it, and I know that 20 pounds is being put into it, and 50 pounds is fighting back. You know, it's a 50-pound block, and I have to push or pull with 20 pounds. I now have the force of the resistance and the force of the effort right here. So that's going to be the force of the resistance over the force of the effort. And so now I have the force of the resistance is 50 pounds, and the force of the effort is 20 pounds. And what that equals out to is going to be 2.5. Okay, it's a little bit different than the IMA. Okay, so we've got 2.5 is what our actual mechanical advantage was. 3.75 is what it would be for ideal. Now remember, ideal is no friction, no nothing. So this is like a super oiled ramp in outer space. There's no air resistance, there's no friction or anything. But in real life, you might get something like a 2.5. Okay, so now the final thing is to go ahead and find our efficiency. So efficiency is equal to actual mechanical advantage over ideal mechanical advantage. Okay, and our actual mechanical advantage was 2.5, and our ideal mechanical advantage was 3.75. And so if we calculate those out, you come out with 0.67 or 67. Whoops, kind of messed that up a little bit. Or 67%. Okay, so our efficiency is 67%. All right, actual mechanical advantage 2.5, ideal mechanical advantage of 3.75. So that's the ramp. Now, what happens if you find out that maybe you've got a ramp here? So let's see, we'll draw a ramp here, and we might not know how many feet that is, but we know that this is 10. Actually, scratch that. We're going to say that this one here is 5 feet, and we don't know how far this guy is. Okay, so in order to find out our mechanical advantages, we need to know what is this distance here, okay, which is L. And if we don't know that, we can use Pythagorean's theorem to solve that. So Pythagorean's theorem is a squared plus b squared equals c squared. And so if this is a, this is b, and this is c, I can say that 10 squared is, excuse me, oops, let me just fix that. 10 squared plus 5 squared is equal to c squared. Okay, so I know that basically the square root of 10 squared plus 5 squared is equal to c. Okay, so basically I have the square root of 10 times 10 is 100 plus 5 times 5 is 25. So the square root of 125 is equal to c. Okay, once I know that, now I have c, which I can then plug in right there. Okay, so that'll give me my length, and then it's a matter of just measuring everything else. Okay, so that's the inclined plane. It's very simple. We'll be able to test it in class, and next up, that should cover most of the simple machines that we're going to be dealing with. We'll be able to do these labs in class. So we'll see you next time.